Hi everyone, today we are going to see the two different types of sources. What are they? Coherent and incoherent sources. So what are coherent sources? Coherent sources are those light source which emits light waves of same frequency and zero or constant phase difference. So what do you mean by zero or constant phase difference? Let us see this one. These are the examples of a coherent sources. These light waves, you can see they are regular, their phase is constant. Here also, whatever crusts are there, troughs are there, their position is not changing at all. Sometimes another example means one wave is like this, another wave just similar to that. This one is also example. Here the phase difference, you can see phase difference is 0 because both are starting from same point only. So phase difference is 0. But here you can see there is a phase difference because they are not starting in same manner. You can see here one wave's crest, but this is one wave's trough. Here what is happening means their phases are not constant, the same, but still it is maintaining as constant. See this one, whenever crest is there, trough is coming. So they are maintaining that. So what are coherent sources? The sources in which they have either they have zero phase difference or constant. Whatever phase difference they are having, it should carry over. Okay, there should not be any difference when the wave is moving. That is the meaning of coherent sources. Let us see what are incoherent sources. These are the sources which emits waves that have random frequencies and phase difference. See this one? Their frequency is unpredictable, they are random, they are changing. After each and every second they are changing. Okay, there is no any constancy between them. Such such types of coherent sources are known as incoherent sources. See this one? An example is usual waves pattern formed by night lamp, whatever it is. Can you see? The waves are irregular. They are not maintaining any constant phase difference. They are irregular. See this one? There is no any regularity between them. Okay. This type of irregular waves, because their phases are not at all similar, they are changing each and every second. Such sources which are we call as what? Incoherent sources. What is the best example of a coherent source? You know, laser light. Okay. It is considered to be more coherent. Okay. Always it is having same frequency, same phase difference at all and all. Okay. So these are the two types of sources we are going to discuss. That is, one is coherent source, other one is incoherent source. Coherent source means they have phase difference. Okay. Either it can be 0 or constant. This is the example where the phases are 0 because their origin is same. This is the example where the phase is there, phase difference is there, but still they are maintaining it throughout. There is no any change further when it is moving. So this is called coherent sources. This is incoherent. Incoherent means their wave pattern is not regular because their phase, frequency, everything is changing after a time. Okay, that is why it is called incoherent source. So these are the two types of major sources we are discussing, coherent and incoherent, and in this chapter, in coming topics and all, we will be discussing about Young's double slit experiment and all, where we are using coherent source only, because incoherent source we cannot predict anything. So when the experiments are going on, we are using only coherent sources to demonstrate. Coherent sources are only stable. So in the further experiment, we will be using coherent sources only. Okay, is it clear? Yes. That's it. Next is, we are going to discuss about superposition of waves. Okay. Next we are going to discuss very important topic, which is superposition of waves. Superposition. Now what do you mean by superposition of waves? Let us see. Superposition is defined as the resultant displacement produced by a number of waves is the vector sum of displacement produced by each one of them. What does it mean? Suppose we are considering a number of waves, one wave, another wave and another wave like that. Suppose we have to find out the displacement at this point. Suppose the displacement of first wave is y1, the displacement of next wave is y2 and so on, y3 like that so on. What is the resultant displacement at this point? It will be y resultant, which is equal to y1 plus y2 plus y3 and so on. Okay, so this is what exactly superposition of waves says. That means whenever the waves are combined or superimposed, what happened? The resultant displacement is nothing but the vector sum of individual displacement. Just take the addition, just add them, you will get the resultant displacement. That is what superposition principle states. Is it clear? Yes. In that way also, there are two types of superposition. What are they? One is constructive superposition or constructive overlap. The next one is destructive overlap. So these are the two. One is what? Constructive, other one is destructive. I'll show you the diagram. What are they? Now what is a constructive overlap? When the two waves are overlap, when they are crests or troughs together. So there will be a bigger wave formed. That is called constructive. From the term itself you can see it is increasing in amplitude. That is called it is constructive. Now what about destructive? That means the output is not there. So you can guess what is happening. A crest of one wave is superimposed with the trough of the other wave. So that is called destructive overlap. Let us see what is destructive. Yes, this is the diagram of constructive and destructive wave. See, you can see two examples here. Here waves are in phase. See this one. This is one wave. See, this is one wave. This is another wave. You can see that their origin is same. You can see if I plot like this, you can see they are completely in phase. See, they are starting from origin and they are maintaining the phase. So they are completely in phase, zero phase difference. So such waves are combined. You can see this is the crest of first wave. This is the crest of next wave. They are combined. So crest and crest together. So what happened means you will get another wave. Constructive overlap means it will be a bigger one. Okay. So this is it. So as a result of constructive overlap, you will get a bigger wave compared to these two. Okay. So what is constructive overlap? If the crest of one wave is combined with the crest of other wave, or trough of one wave also can be combined with the trough of another wave, you will get a resultant wave as a bigger one. That is called constructive overlap. Okay. In the same way, we will be defining about constructive interference. Same thing. Okay. Similarly, you can see what is a destructive overlap. See this one. Here you can see a small wave like this, and you can see another wave, and can you see the crest of this wave is combined with the trough of the other wave. Not like crest and crest together. Crest of one wave is combined with trough of the other wave. So what is the resultant displacement? No. Because this one is act as a positive value and this one will act as a negative value. When they combine, nothing is happening. Okay. So this is an example of what? Destructive overlap. That means the waves are cancel out. Is it clear? So what are the two types of overlaps or waveforms? First one is constructive overlap, next one is destructive overlap. In constructive overlap, crest of one wave is combined with the crest of another wave, or trough of one wave is combined with the trough of another wave. We will get a bigger wave. That is called constructive overlap. What is destructive overlap? The crest of one wave is combining with the trough of another wave. So positive and negative, just like that, you can imagine. So the resultant will be zero. That is called destructive. So these are the type of overlaps, and in further class we will be studying about interference. Same thing. The phenomenon of superposition of waves is otherwise known as interference. Interference also are of two types, constructive interference and destructive interference. We will be discussing that only in upcoming class. Hope you understood the topic. For the upcoming sessions, like, share and subscribe. Thank you.